Hello, students. Welcome back to MathsGenii, and this is the third part of conic section. And today we're going to discuss about hyperbola. I recommend before this video you watch part two, which is ellipse, because both are very similar. Now, let's move ahead. Firstly, we're going to look at some interesting applications of the hyperbola. So here what you see is, let me first, before you imagine where is the hyperbola, so here, this is the hyperbola. The vertical section that you see is your hyperbola. Okay, this. Now what is this? This is the heat processing, the cooling towers. Now why are they used, and why is the hyperbola shape present here? These are used for in the larger industry where heat dissipation is a problem. So that is why, to dissipate heat, to remove out heat, so you see these vapors, right? These are hot vapors. So remove the humidity, these cooling towers are used. Now, why did they choose this shape only? Why did they choose hyperbola? They chose hyperbola because the structure can withstand winds. So, the higher winds that come, the turbulence that comes, this hyperbola can bear it. Another very important thing why they chose hyperbola is because you see the shape. If you had taken a rectangle, the material used would be large, but the material used in this is lesser as compared to this, and also the structure can withstand high winds. So this is one of the applications, if you want to know. Another one, if I talk about, is the lamps. So in the lampshade you see this shadow, right? It's hyperbola shape, just so that you know how a vertical hyperbola looks like. So this was some basic introduction in terms of applications. Now I would really like you to know the ellipse first, so you can go watch my ellipse video. It's a beautiful video explained in details. But I'm going to recap quickly what we learned in ellipse. So in ellipse, if I talk about the distance, here you have d1, here you have d2. Similarly, here too you have d1 and you have d2. What are the similarities and what are the differences in a ellipse? And this is your hyperbola. Here you have something called as d1 plus d2. Here you have d1 plus d2. This is the definition of ellipse. I'm going to show it to you. And d1 plus d2, wherever you move, it's going to be constant. If d1 plus d2 value is 20, even if I move, this is from the foci, even if I move anywhere, the value is going to be 20. So the sum remains constant. But what is the case with this? The difference remains constant. If d1 minus d2 is 10, wherever you move d1 minus d2, it's going to be 10. We are going to see that in details. So what is an ellipse? Ellipse is nothing but the sum of the distance from two given point is constant. Sum of the distance from any two given fixed points, which is the foci, is constant. This is what your ellipse tells you. Let's check what hyperbola tells you. Hyperbola tells you that their difference is constant. Now you will tell me, ma'am, what if the difference is negative? When will the difference come negative? If you are taking bigger number minus smaller number. For example, if your this is your d1, this is your d2. If your d1 was, say, 20 and your d2 was, say, 5, now d1 minus d2, difference is constant. d1 minus d2 is constant. Will you do 20 minus 5, which will give you 15, or you will do 5 minus 20? How will you know that? 5 minus 20 will give you minus 15. Minus sign is never accepted. So that is why there is a note. that I would like you guys to see. So what is the note? Farther point, or if you don't understand farther point, I've written something in bracket. The bigger value minus the smaller value is your distance. Correct? Understood? This note is very important because students get confused ki ma'am, my distance is coming negative. Distance cannot come negative because there we have this note. Okay, bigger value minus smaller value is what you have to follow. This should be your approach. Now, as I told you, this d1, d2. For example, I said that distance d2 is bigger here, right? So if d2 was example, let us take d2 as 10 and d1 as 8. So d2 minus d1 will be your distance. Say 10 minus 8, 2. So d1 minus d2 is your distance. But what if I add another distance? In this case, your d1 is larger. For example, maybe your d1 became, let me use another color. So if your d1 became like 12, okay, and your d2 is 10. So what will you do this time? For this, you will do d1 minus d2. I told you, right? Bigger number minus smaller number. So 12 minus 10. You will get 2. So here also you have 2 and here also you have 2. So what did I tell you? The difference remains constant. If even if I draw d1 d2 here from the foci, the difference is going to be 2 always. This is the property of hyperbola, that the difference d1 minus d2 or bigger number minus smaller distance is always a constant number. In this case we have 2. So I hope this concept is super clear. Again, the same thing that has been told here. See, if you have this is your f1, so this is your hero in the story, f1 and f2. So you have p1 f1 minus, see you have here p1 f2 minus p1 f1. Let me take a pointer. You have p1 f1 and p1 f2. This difference is equal to f1 p3 minus p3 f2. Now let's take at p2, f1 p2 and f2 p2. All the differences is going to be a same number. Like we had seen in the previous slide, we had seen that all the difference was 2. So all the difference is the same number. Okay, now comes the twist in the story. As I had promised that we are going to revise ellipse as well as learn parabola using ellipse. So I had told you in the previous video that there are two kinds of ellipse. One is the horizontal and another one is vertical. And these are the equation of the ellipse. I have also taken derivation in the last video, so you can go check out. So in hyperbola also, you have horizontal hyperbola and you have vertical hyperbola. I'm just using the same terms so that you understand. Okay. Now let's look at the equations. Okay. For this hyperbola, vertical hyperbola. Okay. For vertical hyperbola, your equation is x square upon a square. See, I'm comparing. Keep comparing. Okay. Y square upon b square is equal to 1. Where is the difference? The difference from parabola and hyperbola is just the sign. Here you have a negative sign, and in the vertical, in the horizontal ellipse, you have a positive sign, and in the horizontal hyperbola, you have a negative sign. So this was for vertical. Now let's look for the equation for the horizontal one. Okay. So here the equation changes. Just ignore this fact. Just keep in mind that you have y square upon a square in this case. Y square upon a square. Then you have x square upon b square. Again, the sign changes. Here you have plus. I have here minus is equal to 1. So these are the equations. We are going to look at how this equation comes, what is A, what is B, what is C, what is E, what is L. I'm going to show all of it to you. But for now, for this slide, just remember, students get confused with the equation of ellipse and hyperbola. So this is a good technique to sort of remember what are the equations. Let's look in deep details. Okay, so first you have something called as the foci of the hyperbola. So this is a vertical hyperbola. That means x is your hero. On the x-axis, whatever you have, let me just tell you one short quick thing. Of course, you know this from like a very lower standard. If I have something like 2 here, so what will I write? 0 comma 2 will be the coordinates. Why? Because on x-axis, sorry, it is going to be, let me clear this. If you have 2 here, so it's going to be 2 comma 0. Why? Because on x-axis the y component is not there only, na. This is x-axis. Where is y component? So y component is 0. So that is why on foci is on x-axis, so y component is 0. So you have 0 here and 0 in place of y. This is x, this is y. Similarly with focus is represented by c. So c comma 0, 0 y, because on x axis y term is 0. And this on the negative side, this is, for example, you had minus 2 here. This on the negative side, so you have minus c comma 0. Okay, I hope this is super clear. Okay, now let me erase all this. So foci is clear. Center of the hyperbola. As you can see, the center of the hyperbola is nothing but the midpoint. And center of the hyperbola in case of standard equation, because this is passing through the origin. In case of standard equation, the center is always what? 0 comma 0 origin. Okay. Now there are two axes that you can see. One is, I have named two axes. One is the transverse axis and another one is conjugate axis. I will tell you this also in detail. What do you mean by transverse? What is the conjugate? Okay. What do you mean by transverse axis? Transverse axis is the one which passes through the two foci. Okay. So this is the transverse axis. This is passing through foci. And even in ellipse, the equation of transverse of axis was 2a. Transverse axis equation was 2a. Next is conjugate axis, the axis which is perpendicular. This is your transverse axis. So this axis is perpendicular. So this is called as conjugate axis. Okay. Then you have vertices. Very important. In ellipse, you had only one vertex. In ellipse, you had only one vertex. But that's not the case with hyperbola. The vertex here, see, vertex. Where is the word vertex written? Here and here. So the vertex is, again, the y component will be 0 and vertex is represented by a. So a comma 0, and here you have minus a comma 0. Okay. Then you have one more interesting thing. What are these orange lines, you may ask? The lines drawn parallel to the hyperbola assumed to touch hyperbola at infinity. These are called as asymptotes. These are called as asymptotes. These are just imaginary lines that they consider कि when they will go to infinity, that lines will touch. When you expand this, these lines will touch at infinity. If you keep going till infinity, these lines will touch somewhere. This is called as asymptotes. Asymptotes are taken nothing but for ease of calculation only. Okay. Now let's just in detail see where to write A, where to write B, where to write C in comparison with ellipse. Before that, this is your transverse axis definition. The axis that includes foci. Always remember. Now, why is this so important to know? VVIMP to understand this concept. Why am I telling you this? See, in case of vertical, in case of horizontal hyperbola, the focus is here, F, F. Okay, so this is passing through F. So in case of the horizontal hyperbola, the transverse axis is uh, the x-axis, and in case of vertical hyperbola, where is the foci? Here and here. Foci is passing through which axis? We are saying transverse axis, meaning is what? Foci should be passing through that axis, and foci is passing through what axis? Y axis. So in case of vertical hyperbola, the transverse axis is nothing but y axis, and conjugate axis is nothing but the axis which is perpendicular. So conjugate axis does not really matter. What matters is you should know that what is transverse axis when anyone is asking you in the question. Now let's look at what we already know. We already know about ellipse, and this is the diagram that I had explained in details in my ellipse video, but it's important for you to actually kind of know this right now. Okay, now let's do the plotting. uh so here you have, you in case of ellipse you have two foci, so here also let me just plot f2, this is your f1. Then you see from 0, okay, let me take origin also. Now look at the ellipse diagram. Always try to draw similarities instead of remembering. Okay, now in with the ellipse diagram, what do you see? From 0 to f2, what is the distance? C. From 0 to f1, what is the distance? C. So again, the same thing will follow here. From 0 to f1, your distance is C. From 0 to f2, your distance is C. Now look at A. What is the distance of A? So this is your vertex in case of uh, the ellipse. So from the curve, okay, look at the curve. From 0 to the curve, the distance is A. Similarly, from 0 to the curve, from 0 to the curve, the distance is going to be A. Agreed? So this is A, this is A. Okay. Now you have something called as B. Okay. Now for B, here we will have to make some assumptions. The B here is not as simple as the B on the ellipse side. So let me just draw some assumptions. Okay. Let me draw a line here. Okay. Just consider a line passing through the origin, and these will meet the hyperbola somewhere at asymptotes, the one I had explained in the last slide. Now when I draw a perpendicular line or a tangent, when I draw a tangent to this curve, when I draw a tangent to this curve vertically, and I draw a tangent this side. Again, I draw a tangent downwards. I draw a tangent from this side and from this side. This is not looking like a square, but assume that it is a square. So this distance is B. Okay. And this is B, this is B, and this is B. So let me just clear all this mess and we'll just draw it clean one last time. Okay. So now that you are familiar with it, I'll go fast. So these were two foci. This is 0 from foci. You have C. From the curves, you have A, and here you have some square distance, some square that is coming up. Imagine that there's a square here because of the asymptotes. This distance is B. So you have A, you have B, and you have C. Okay. So this was the case with the vertical part of it, horizontal. Now we'll look at the vertical hyperbola. So this is how your vertical hyperbola looks like. Now, similarly, we will do parts of vertical hyperbola as I did for horizontal one. Okay. Foci of hyperbola in this case is 0 comma c. Why 0 comma c? Because if you want to plot something like 3 here, so what will be the coordinates of this? It will be 0 comma 3, because on the y axis there is no x, so x is always 0. So in this case your first term, which is x, is 0. So your foci is 0 comma c and 0 comma minus c. Okay. So I wanted to actually erase it. Then you have center of the hyperbola, which is midpoint. Transverse axis in case is this. Transverse axis is y axis. In the horizontal case it was x axis. Y transverse axis, we just saw the definition, the line passing through the foci. Then conjugate axis is of course the remaining axis. Transverse axis is 2a, so conjugate axis will be 2b. Vertices, very important. Again, x component will be 0. Why? Because it is lying on the y axis. So your vertex lies here. This is your vertex on the negative y axis. So it is 0 minus a. This is on the positive y axis. So this is 0 comma a. Okay, so why am I showing this slide is because this is from my past video of ellipse, and I have derived the equation of relationship between semi-major axis, semi-minor axis, and the distance of the foci. The terms here will change. So in ellipse you have something called as major and minor axis. In terms of hyperbola you have transverse and conjugate axis. But why am I showing the previous slide of ellipse? It's the slide from the ellipse video for this equation. Now you will come to know in a second why I have shown this slide, because students get confused. So this is your the hyperbola that we are discussing. This is the relationship between uh between ABC in hyperbola. What is the difference? Let me write this in terms of b square. So a square, c square goes that side, becomes minus c square. Here you have a square minus c square. Here you have c square minus a square. Why is it so? Why? Just think for a minute. Why? So, why in this case you have c small and a larger? C is small and A is large. Therefore, A minus C. A is bigger and C is smaller. But in case of your hyperbola, C is big and A is the smaller value. So C square minus A square is equal to B square. And in terms of ellipse, you have A square minus C square. Here you have C square minus. Okay. So that's it. Let's move ahead. Eccentricity. So you'll remember that formula is what I'm assuming. You must have taken a screenshot of the similarities. Okay, eccentricity. The same thing I've explained. Eccentricity, the formal definition of eccentricity, and then we'll look at the informal one also. Okay, eccentricity is nothing but the ratio of the foci to the vertice, that is c upon a. The formula remains constant for everything, for circle, hyperbola, parabola, everything. The formula is going to remain the same. Okay, so this is your eccentricity formula. Let's look at the informal part of it. Okay, should I just derive eccentricity, or we'll do it a little later? Eccentricity is nothing but how circular your object is. So eccentricity of circle is 0. Eccentricity of ellipse is between 0 to 1. And eccentricity of a line, eccentricity of a line is infinite. It is infinite. Why? Because it is nowhere close to the circle. So how circular your object is means eccentricity. I'll just quickly derive eccentricity for you. There's no harm in it. Let's go back. Okay, so pay careful attention on how I'm deriving eccentricity. In the previous slide, let me just recap. What did we write? The relation. It was a square plus b square is equal to c square. This was the relation we wrote. Okay. Eccentricity formula, I just told you the formula remains same for any shape. Eccentricity formula is E is equal to c upon a. Okay. Now in the next slide you might have seen, in this slide you might have seen that I was saying that the eccentricity of your hyperbola is greater than 1. I will prove it to you why eccentricity of hyperbola is greater than 1. You might have seen that this is your c and this is your a. So C is bigger than A. Clearly, you can see that. So C is greater than A. Okay. So can I take this A in the denominator? What is left? Nothing. So 1. What did I basically do here is divide by A, divide by A. A gets cancelled, remains 1. Okay. But what is C upon A? What is C upon A? E. So E is greater than 1 for hyperbola. Okay, understood. And for ellipse you've seen that already, but just recapping, for ellipse you have eccentricity as less than 1. E less than 1. Why? The opposite logic. I just told you that in case of ellipse your A is greater than C. So that is why if I take the eccentricity part, so it will become E is lesser than 1. So this was for ellipse. It's not needed here, but just a recap. So I'll just remove this part. Okay, now let me tell you an okay, ABC we saw. Now let's see what happens with ABCE. All the 4 terms involved. What can we do with it? Let's just play around. Let's just play around a little. Okay. Uh let me do something. So can I send this A, which is in multiplication, to this side? So it will become AE. So C is equal to AE. Let me put it in this equation. This equation was A square plus B square is equal to C square. Let me just substitute the value of C here. So C square. So both of these will get square. Now, what I'll do is I'll keep b square on this side alone, and I'll send your a square on that side. So now when I take a square common, you get e square minus 1. So this is your relationship between b, a and e. This also could be used in a lot of questions, especially in the competitive exams. So now you know from where eccentricity has come and how you can easily derive, even if you forgot this equation. It's just two-step derivation. So you can derive it by yourself in the exam very easily. Okay? So one important thing, now that we are done with all the parts, we are done with a, b, c, e, all the parts of your hyperbola. Now I would like to show you one more interesting thing. This is what you already know. You will tell me, why am I showing it to you again? This is what you already know. The equation is x square upon a square minus y square upon b square is equal to 1. This type of hyperbola you already know. But what if I'm shifting it? I am shifting it, and I'm shifting one more. I'm shifting this to this side, I'm shifting this to this side. What will happen? These asymptotes and this origin is the hero right now. Just focus on the origin. This origin will shift as your hyperbola is shifting. And when this origin shifts, what will happen is you will have a new point here. You'll have a new point here. Now the equation is changing. Now pay careful attention on how this equation is changing. You have upon a square, you have minus, you have upon b square, you have 1. Here you had 0 comma 0. Let me do one thing. Let me rename this two new points that I have obtained as h comma k. I have explained h comma k in great details in my ellipse video. So for now you can say that h comma k is the new shifted origin. So h comma k. So you have x minus h square. Instead of x square, you have x minus h square. And instead of y square, you have y minus k square. So this is your equation when it's a shifted. It's not a standard. This is your standard hyperbola equation. And this is the shifted origin. This is there in ellipse also, this is there in circle also, so you can watch any of the previous videos. Now not a lot of people cover this, but this is not even in your syllabus, equation of asymptotes, but I would just quickly tell you how to derive it in case this comes up in some exams, and you might not want to lose marks. So let me do one thing is, this asymptote will be in terms of y square. So I'm going to isolate this y square, and this entire term I'll send to this side. So it will become 1 minus x square upon a square. And you have minus y square upon b square left this side. Correct? So what I'll do is, I will send this minus and this b square to this side. Okay, can I do that? Of course I can do that. So it will be minus b square and this bracket. Okay, now when I open the bracket, I will have this a square, I'm multiplying this side. So I have a square minus x square upon a square into b square. Now this minus sign I will shift. So this will become minus and this will become plus. Okay. Now, when I take the square root, it will become root of b square upon a square and x square minus a square. So this is your equation of asymptotes. This is not included in any board syllabus and I've not seen questions on this, but may appear in JEE. So you can easily derive even if you don't want to remember. So this is a super quick recap of what we have learned so far and what is the comparison. Comparison is always, comparison tables are important so that you remember. You can make the comparison by yourself as well. You can skip this part and you can go to the questions that I've solved. But those who want a quick uh, recap. So length of transverse axis is 2a. Uh, length of, I'm not writing everything, I'm just writing what is important. Okay. Length of transverse axis is to b. Then vertices, again very important. So you have plus or minus a comma 0, because here your hero is x. In this case it is your hero is y. So here your hero is y and here your hero is x. uh, Again, foci c comma 0, or c is also, so I'll just write it here first. E is what? C upon a. So c is nothing but ae. So instead of c, can I write ae? So you have ae comma 0. Again, plus minus. In this case you have, this is also plus minus. Here your hero is y, so I have only y component, or 0 comma plus minus ae. This is your formula. Then directrix, not very important, but still I'll write x is equal to plus minus a by e. And here you will of course have y, so y plus minus b by e. Center is 0 comma 0 both ways. Eccentricity formula, E is equal to C upon A. All of you know that. Then length of lattice rectum, very important. Very, very important. Length of lattice rectum is same as that of your ellipse, 2a square upon b. And for conjugate hyperbola, it's, or the vertical hyperbola, it's the opposite. Sorry. Here you have 2b square upon a, and here you have the opposite, 2a square upon b. This was a small comparison. Now let's just quickly get to the questions. Find the transverse axis. Firstly, which axis is the transverse axis, x or y? He's asking me which axis is the transverse axis, x or y. Here, look at the positive term. Positive, here's a tip or a trick that I'll give you. Always look at the positive term, where the positive term is, and you will have your transverse axis. Tip is, look at the positive value. That is your transverse axis. So here the positive value is x. So your x is the transverse axis. Then he's asking me center. It's a standard parabola. You don't have anything in numerator such as x minus 2 square or something for you to have any center. You don't have any center here. So you have center as 0 comma 0. Then next he's asking me foci. Okay. Now what do I understand by this equation first? This is your given equation. And the equation that I know is what? X square a square minus y square b square is equal to 1. So can I compare a square with 4 and b square with 9? If I compare a square with 4, this square goes that side, becomes root. So you'll have 2. So a is nothing but 2 and b is nothing but b square is equal to 9. So b is nothing but 3. Okay, I'm going slow as this is the first question. Okay, you can always pause the video, check the final answer, go ahead to the tougher questions. Okay, so you have A, you have B. Now he's asking me foci. Foci is nothing but C comma 0 plus minus, or you don't have C here. So I know of one relation that I have seen few slides back, that C square is equal to A square plus B square. This is the relation that I had seen. I want C. So I will shift this square, that side becomes square root plus minus square root of A square plus B square. So this is also one of the formula of foci. Plus minus root of A square plus B square comma 0. Okay. Now you can easily calculate and write the answer. This is A square, this is B square, and comma 0. So you have your answer as plus minus root of A square is 4, B square is 9, comma 0. So your answer is plus minus root of 13, comma 0. Okay, let's look at more tougher questions. This was just a warm up for you guys. Now, this is not in a standard form. First step always. So that question was already in standard form. See, you had 1 this side. It was already in the standard form. This question is not in the standard form. So I want 1 this side. So what I'll do is I'll divide the entire equation by 16. So when I divide and this 16 gets cancelled. So you have y square upon 1 minus 16, and here you have 1. Now what is the transverse axis? X or y? Remember the tip. The positive one is the transverse axis. So your transverse axis answer is y. Center. Center is again 0 comma 0. Why 0 comma 0? If you had something like y minus 3 square upon 1 minus x plus 4, anything in the numerator like this, then your center would have been positive 3 and negative 4, h comma k. But this is not the case in this question. So 0 comma 0 is your center. Find the vertices of the hyperbola and find the foci of the hyperbola. Okay, pretty simple. So this is my standard equation. So let me take So what is your standard equation for this? You have y square upon a square minus x square upon b square is equal to 1. So just compare and you will have your values of a and b, because heroes in the question are a and b only. So if I compare, this is a square and this is b square, correct? So a square is equal to 1. So a is equal to root of 1, which is 1. B square is equal to 16. So b is equal to root 16. So b is equal to 4. So your a is 1 and b is 4. Heroes in the question. Okay. So these are just background work. You have to do this in your mind. You don't have to do it on paper. Okay. Then he's asking me what? Vertices. Vertices is nothing but plus minus. Now look at this very carefully. We had done the formula sheet that you have y-axis, and on y-axis x coordinate is 0. So 0 comma 0 comma what? Plus minus of A is your vertices formula. If it had asked me vertices, if the transverse axis was X, the vertices would have been plus minus A comma 0. But your transverse axis is Y. So Y is the hero. There is no X present. So your vertices is 0 comma plus minus 1. Then let's talk about foci. Foci is nothing but, what is the formula? Foci we just saw. Again, y is the hero, so x will be 0. Y is the hero, x will be 0. Foci formula we just saw. So foci is 0 plus minus a square 1 square, 4 square is 16, 16 plus 1, 17. Okay. Let me see if this is a question that could challenge you, or it is the next question that could challenge you. Okay. This will cover every aspect. This is already in the standard form. What standard form it is? Write the comparing equation. X square upon a square minus y square upon b square is equal to 1. A square is 16, so a is 4. B square is 9, so b is 3. So if you notice, I'm going faster in this question because I've already taught you how to do things. So a and b you have. Okay. So you will also develop speed once you practice like 5 questions and you're done. You will have a very good speed. You can directly write. Then you have something called as they are asking you what is the coordinate of foci. Fast, be quick. What is your hero in this? Positive term is x. So x axis is the hero. So for x, y term is 0. Okay. Then he's asking you the coordinates of foci. So it's plus minus root of a square plus b square. It's plus minus root of a square is 16, b square is 9, comma 0. So 16 plus 9, 25. 25 square root is what? 5. So your foci is here. Next thing is asking you is vertices. Vertices again very simple. Who is the hero in the story? X. So your y component will be 0. Vertices formula is plus minus a. So plus minus 4 comma 0 is your answer. Then you have the next thing is asking you eccentricity. Eccentricity is what? C comma a, c upon a. This is your c. This is actually your c. Because you remember c formula was root of a square plus b square. You already have c value as 5. So 5 upon 4. Okay. You just calculated this, right? That c is 5. Here I directly written f formula is a square plus b square is equal to 0, or there's one more formula of f, the basic formula, which is c comma 0. So c is nothing but 5 only. So this is the eccentricity formula, same for all the shapes: circle, parabola, hyperbola, ellipse. C upon a is the standard formula. Latus rectum formula we just saw in the previous slide. It was 2b square upon a. So 2 into b square is 9 upon a. So it is 1 2 So 9 upon 2 is your answer. So pretty simple. The question was pretty simple. Now let me see if I have some different kind of question, and that would be okay. Good question. Now equation is not given. A different question here. The equation is not given. So what we will do is, you have 0 in place of x. How do you understand who's the hero in the story? This is x, this is y, correct? X comma y, this is how you write it. So x is 0. So your hero, x is 0. So your hero is y. So you need to remember the y formula. What was the y formula? It was y square upon a square minus x square upon b square is equal to 1. This was the formula. This is what I'm going to use. Now, what he has given me? Vertices. Vertices of vertices. When y is a hero, go back to the formula sheet. Actually, you don't need to refer to the formula sheet. Vertices is represented by what letter? A. So 0 plus minus A. So your A value when you compare is 3. Now look at the foci. Let me write it separately. Foci is represented by what letter? C. So 0 plus minus C is the foci formula. So C is what? If I compare 0 with 0, I've compared, and C with 5. So you have C as 5 and A as 3. Now I know a relationship between A, B, C. What is the relationship between A, B, C? That also we have seen in the previous slide. It's C square is equal to A square plus B square. Correct? C square is 25. A square is 9 plus B square. So you have 25 minus 9 is equal to B square. So 25 minus 9 is 16. So 16 is equal to B square. Therefore, B is nothing but 4. So you have A as 3, B as 4, and C as 5. Find the equation here told. So for equation, I just have to substitute. I already have the standard equation. I'll just put the values of a square, b square, c square. A square is 9 minus x square. B square is 4, which is b square is 16 is equal to 1. This is my answer. Pretty simple. Thanks guys for watching. Stay tuned and watch the previous videos to have a great hang of the topic conic sections. See you in the next video.